In this research, we're talking about sodium percarbonate, also referred to as emergency oxygen powder. When it dissolved in water, it released hydrogen peroxide, which make aquatic products such as fishes and shrimps become lively to earn a good sell. Actually, excess peroxide would be harmful to our body. Our topic was divided into 3 parts. The first part was for synthesis of titanium dioxide as a photocatalyst to decompose the hydrogen dioxide which remained in water. The second part was for detection of hydrogen peroxide. There are 4 steps in our synthesis process. First, we mix the water, hydrogen peroxide, and titanium sulfate. And then by heating and filtering, we can get a yellow powder. After calcination, we can get a titanium dioxide. Here, we already knew that we need at least 40 minutes to reach the maximum weight. And the hydrogen peroxide in demand must be optimal because of its high catalytic performance. As for the calcination temperature, we choose 500 degrees Celsius due to the forming of anatase phase and consideration of the surface area. In further, we improve the catalytic performance of synthesized titanium dioxide by adding citric acid in the heating process. This idea was originated from a Bendix reagent. In practical, we change the appearance of titanium dioxide from powder into balls by the parameter that we have done before. Its size is about 1.2 mm to reach the highest material economy. In performance, our material performs better than the commercial one. It means our material is a better candidate to turn the titanium dioxide into balls. Titanium ion is a good thing. It can not only be used to synthesize the photocatalyst, but also for detecting reagents. When titanium ion acts with hydrogen peroxide, the color of the colorimetric reagent turns yellow. To establish a calibration line, we use 410 nanometer as a detecting wavelength. Next, we make sure its counterion, that is sulfate ion, is inert, and the reactant, that is titanium ion, must be sufficient for the calibration line work normally. After the calibration line was established, we expected that it can also be worked on the system of the sodium percarbonate, but to our surprise, it still remained colorless. After reading the references, we found that the pH value interferes with the results, so we select the buffer in pH 3 to confirm its sensibility. To make the testing process more friendly to people, we turned the reagent solution into a test paper, and it has the potential on detecting the sodium percarbonate, and the commercial one didn't. This is a way to check out the commercial morality, and this is the sale point of our research. In the future work, we discovered the vanadium ion was potential to be substituted for titanium ion. It was in success to establish a calibration line to determine the concentration of hydrogen peroxide. Even though there are still several problems waiting to be solved, it still had a potential to develop.